Hello everybody, my name is Hassan Nafid. I am an anatomy and physiology instructor at Madison College in Wisconsin. Tonight we're going to share the dissection of the brain. We're going to use a sheep brain to perform our dissection and show you the parts of the brain. Sheep brain is similar to the human brain with some differences. When we come across these differences, we will share them with you. I have a pre-dissected sheep brain and a brain that is not dissected that we're going to dissect together. First of all, let me show you the surface anatomy and the parts of the sheep brain. I have this brain here in my hands. This is the frontal part and this is the back of it. Here we are looking at the frontal lobe and we're looking at the two olfactory bulbs, and they are big and well developed in a sheep or in animals in general, because animals depend on the sense of smell. That's why it is well developed and it is larger. This side you're looking at, this is the parietal lobe, and this part here, if I turn it this way, this is your temporal lobe. What you're looking at in the back here is the occipital lobe, and this is our cerebellum. Also, the brain of the sheep is divided just like the human brain into major four parts: the cerebrum, the cerebellum, the brain stem, and the diencephalon, or the part that you're going to see when we dissect and open the brain into two hemispheres or two equal halves. I want to show you here the parts of the brain stem before we do the dissection to look at. I'm going to use this brain here that is more obvious to look at these parts. Here is our medulla. This is the medulla oblongata. This is the pons. These two parts, or this area, lift that up a little bit. This is the pons. Right? The midbrain is right here. You can look at it from the side also. The midbrain. You can make it a little closer and take a closer look at it to show you. So again, this is our medulla. Of course, this is some clotted blood here, that red color or dark red. This is our pons. And this is our midbrain. If I tilted the brain stem a little bit here, or the cerebellum, this is going to show you your brain stem. I mean your midbrain, I'm sorry. Alright? And the midbrain, of course, is part of the brain stem. We know the brain stem is the medulla, the pons, and the midbrain. And this is the cerebellum. Also, I wanted you to observe and notice with me this part here, which is the sagittal or the mid-sagittal fissure that divides the brain into two hemispheres. And this is our transverse fissure. And the transverse fissure separates the cerebellum from the occipital lobe of the brain. The brain, as you notice, is thrown into folds here. I'm going to use this one to show you. Ups and down, these are the gyri and these are the sulci. So when you see this sunken area, these are the sulci, alright? And these are the gyri here. This one of them, that's the second one, that's the third one, okay? So gyri and sulci. On the bottom of the brain here, I'm going to show you part of the dura mater This is the covering of the brain, the tough covering of the brain. It is the outer covering. Most of it is removed. As you notice, this is the only part that is remaining. So we're just gonna show it to you. And this is the dura mater. These are the two optic nerves, right and left. In the middle, you are going to find the optic chiasma, and that's where the two optic nerves intersect. Good news, the dura mater is not removing this part, so that will enable us to take a look at the pituitary gland, which is here, and it's also, you see it here on this brain. So the dura mater is not removed, because when the meninges are removed all the way, the dura mater automatically will come out. If I showed you here, good news also, because we do have the dura mater, we are able to see our stalk or fundibulum that connects the pituitary gland with the hypothalamus. I'm not sure if that's obvious or not. We'll do the best we can here to have you look at it. So this is our stalk here that connects the dura, that connects the pituitary gland in the front and hang it to the hypothalamus. We know the hypothalamus makes hormones and transport it via this cord or this stalk to the pituitary gland, where they are stored until they are released as releasing or inhibitory factors of the endocrine glands. Also, I am going to show you here the optic nerves and the optic tract. Let me use this here. After the optic nerves unite or cross here in the optic chiasm, they go as an optic tract. The olfactory bulbs will give rise here to the olfactory tract. This is part of the olfactory tract. This is one of them. The other one is removed or is gone. All right. So we are going to move to the next step. So to dissect the brain, we're going to use scalpel, of course, and make a line that is in the middle along the longitudinal or the mid-sagittal fissure to divide this brain into two equal hemispheres. Hopefully we'll make them symmetrical, so we'll be able to save and look at the parts of the diencephalon and the side view of the brain. Good practice is to hold it real well down, and I'm going to try to do the best I can. Gonna go in the middle, try to do the best we can, and make an incision along the midline that will cut the brain into two equal, hopefully two equal hemispheres, and to obtain a nice sections. Well, that's not too bad if you take a look at it here. I'll push it a little bit for you, and maybe put it up for you to look at. I'm going to show you the part that I can look at here and compare with what we have. So here you're looking at the two hemispheres. This is our optic chiasma. You see here? Optic chiasma right in the middle, connecting the two brains. This is our corpus callosum. It is that fibrous tissue that holding the two hemispheres together. If I put them back in there, that's what you see, beginning to split the two corpus callosum. All right. Here is our ventricles. Very obvious too. I'm going to open it a little bit up with the forceps to show you the lateral. There is two lateral ventricles, one on each side. If you look at two lateral ventricles, I'm going to open one here to show you how wide it can be. Look at that. It can be a little wider. You can use the forceps to open it. This is one, and that's the second lateral ventricle. So we got the two lateral ventricles, and then we have the third ventricle, and then we have the fourth ventricle. So you have our two lateral